Hello, this is Lei Zhang from Alibaba, and today, me and my co-speaker Alois from Dynatrace will give you the talk about the cloud-native application delivery landscape update. This is actually a deep dive session for CNCF SIG app delivery. So today, if I am an application developer and I look at the CNCF landscape around the application definition and the development category, it's actually very interesting. The first section I saw is a bunch of databases, which I only heard one or two of them. Why they are part of application definition and deployment? I'm very curious. Should I be some kind of expert on storage engine to write a simple application? Seems not. The second section I saw is a bunch of software with name of streaming and messaging. It's also very weird indeed. I really don't think how Kafka works is a concern for most of the application developers, not to mention the other ones like cloud events, which I would probably never need to know what it is. And for the rest part of the category, it's essentially a mixed box of every application, packaging, and CI/CD related project in the community. Nobody knows nobody knows how they are organized or placed in these sections. It's just a chaos. Honestly speaking, the application category of CNCF Landscape needs a significant update since a long time ago. Today, the modern application delivery actually starts from application developers writing the code and trigger continuous integration process by pushing the code. Then the CI system will generate Docker image as a artifacts of your application. And for the deployment of these artifacts, we will write Kubernetes YAML files to define workload and the operational configurations for your application. These YAML files normally store in, for example, Git, so it can trigger GitOps workflow per every change in these files. When the change reach Kubernetes, the controller, like route controller, will respond and perform the corresponding application delivery functionality, for example, blue-green deployment. This application delivery workflow, which includes GitOps and declarative API, Kubernetes, and controller pattern at its heart, is very different from the traditional CI/CD pipelines. And it also created more emerging technologies and new scopes in this era. It's also another reason that we need to update the CNCF landscape regarding to application delivery because we definitely want to include these emerging efforts as part of the landscape of application delivery we're talking about. So, the first emerging technology we want to include in the new landscape is standard application model. So, why standard application model is important? We all know that Kubernetes is designed for us to build application-level platforms, but in real world, the requirements from our users are highly diverse. For example, some applications are stateful workloads, so we need to build the users a stateful application platform with operational capabilities like manual scaling policies and canary route strategies. However, there are also many applications which are stateless. They use deployment at workloads, Flagger, for example, to do rollout, and HPA for auto-scaling. And for some other applications, they just prefer to go to the serverless style. We have to use Knative, for example. We need to use Knative, for example, to save them. See, although all these platforms have unique traits, they also share a lot in common. For example, all of them requires a capability like Let's Encrypt. But as platform builders, we have to implement this Let's Encrypt functionality in every different platform again and again, since every different platform here speak different languages, speak different APIs. So essentially, the platform builders are creating more fragmentations today, more silos, and more closed systems with a lot of in-house CRDs. This don't feel good. This is where a standard application model can save the world. Essentially, we now have a unified model layer for all application platforms in the organization. They speak APIs such as components and application configurations or any kind of standard application level primitive instead of the infrastructure level primitives, which ensure that we will not leak a lot of too much detail to our users with a unified approach. And every platform here will have their own unique workload and traits to serve different scenarios. And for the common workloads and traits, we don't need to reinvent the wheels anymore, because all these platforms now share a common pool of capabilities. So platform builders just pick what they want to assemble them into their own platforms. It's just easy and neat. In the community, the existing effort to define standard application model for platform builders is Open Application Model, OAM. In detail, OAM defines 4 application level primitives for Kubernetes in the standard approach. Firstly, components. It's all about what workloads you want to deploy. In most cases, they are Kubernetes deployments, but it can also be functions if you want, or your own Kubernetes operators at workload. The second concept is trait, which are used to define how to operate the workloads. Auto-scaling, rollout, traffic management, etc. are all perfect examples of traits. Some of them are provided out of box by Kubernetes, but most of them come from the ecosystem, like Flagger, like Istio. This is also where abstractions mostly happen if you want to make your users' lives easier. The third concept is application configuration. This is a YAML file to explicitly to bind traits to certain components. So you clearly know the topology of your application instead of tracking them by, for example, labels or use other kind of unstructured approaches. The last but most important, the definitions. They are used to register CRD or any Kubernetes API resource as workload and traits. And we will maybe talk about more about this in detail very soon. You can also check its website or specification for this detail, of course. Okay, so let's go to the next step. The second scope we want to include in our landscape is multi-cluster application delivery and GitOps. So why do we want to use multi-cluster? This is a very important question because today we basically have a lot of Kubernetes clusters to manage, not only in our own organization, but also in different organizations. It's a very common pattern. So we want to have better isolation. We want to improve the availability. And we also want to have more flexibility to, for example, to do capacity planning, especially for bursting workloads. And of course, we want to do location affinity, and we want to avoid the vendor lock. These are all the multi-cluster Kubernetes can bring us, the benefits and the values here. But the question is how to deliver applications to these clusters, especially when those clusters belong to different clouds. So the first issue is how we place the applications, the application placement. That is to say how to, for example, deliver the application to a target cluster based on our strategy. The first project you need to take a look at which can solve this problem is the Federation version 2. But of course, the Fed project. But there is a restriction in this project because you need to define federation types for every Kubernetes resource you want to deploy. This is actually very complicated. That's why a lot of people gradually move to a GitOps-based approach, which means you will basically use GitOps with application level placement strategy. And for example, you can use Argo CD to do that. It has a features named is application set for you to define which application goes to this cluster and that application go to that cluster. It's very easy. And also Flux also supports similar pattern. And there are also a lot of commercial products today, for example, Google Anthos, which enable you to deliver application to different target clusters based on your GitOps configuration. But The second issue is a little bit more complicated, which is the portability of your operational capability. For example, I want to deploy my application to multiple clusters in multiple clouds, but how can I define a certain operational capability without need to care about the details of the cloud providers or the different clusters, right? For example, the cloud resources. How can I define a database which is portable between Google Cloud and Microsoft Azure Cloud, right? This is very, very complicated issue. And today, Crossplan can help you solve this kind of problem because it can help you to build a platform agnostic abstraction on top of the cloud resource APIs. But there's more operational capabilities. For example, traffic, ingress, rollout, monitoring. And for traffic management today, there is a ongoing effort which name is SMI for you to define traffic management strategies regardless of what kind of um, service mesh plugins you have, right? This is actually a very good start, but we really need more like this. For example, ingress, right? How can we define ingress specification regardless of its implementation? And there are community effort as well, like ingress v2 API. And also for rollout, for observability. For this part, we have open telemetry, which is very promising, but we don't know how to define a portable definition for auto scaling, for example, as well as service binding. So in one word, the current community is still not there to define generic standards for or interfaces for portable operational capabilities. And it's very hard for us to enable real multi-cluster or multi-cloud application delivery for now. But yes, there are some promising effort, and we should keep our eyes on that. Now, I will let my co-speaker to share more about the rest of the challenges we want to include in the scope of application delivery landscape. So please go ahead.
Thank you, Harry. That's a perfect transition into the next challenge that we want to talk about, which is about packaging and shipping COTS or COTS applications. So, what is a COTS application? COTS means commercial off-the-shelf application. Basically, applications you run within your company that you simply install and use but not develop yourself. A lot of companies in a lot of applications in a modern company are these kind of applications. And the more we move to Kubernetes, the more we can expect more of these applications being also deployed to Kubernetes. It's like a multi-cluster scenario that we were talking about before, but more to an extreme because every cluster is different and we can make no assumptions what the cluster is going to look like, which gets us to that point that we need a kind of basic contract of what to expect from the environment that we deploy to. Currently, we can only rely on the basic platform components of our Kubernetes cluster and not on additional requirements, which the application, however, might have. And ideally, we also have a standardized self-contained packaging format that we could use to deploy this application. So let's look at packaging solutions. So obviously we can use Helm. Helm as a package manager allows us to package all the individual components we need for our application and put them into a Helm chart, but not all components are in the Helm chart, especially the images are not in the Helm chart. And also the target system must have Helm available, otherwise we could not use the Helm chart. We can use an operator. Operators also encapsulate this installation logic and obviously a lot more than just installation logic. But images, again, are still not part of that operator. So it doesn't solve our dependency on the registry side either. We have also something like CNAPs, or Cloud Native Application Bundles, that allow us to package components together, also sign them and do a number of other things as well. And if we use a concept that's called a thick bundle, it comes with the images included. However, we again get a requirement on additional tooling in our cluster. So with these requirements, we have exactly a situation as we've seen it here. On the top, all of our platform assumptions are met. So everything we actually require is also available for us. Ingress, service mesh, storage, other things we require from our Kubernetes cluster to have available. However, when now one of those components is missing, we can't run the application. Like in this case, the service mesh is missing, so we can't run the application. What we could do, though, we could decide that we install the service mesh as a dependency of the application and just ship the application all together with the service mesh. That works fine in certain situations. However, in other situations when there is already a service mesh available, we might run into problems there, or even the environment we install to does not want to have a second service mesh available and requires us to reuse this. So we are getting into a more complex situation here, how to handle this. The next challenge we're looking into is really handling chain of custody for our application delivery. And the next slide should sum this up pretty well. Kubectl applies some file from the internet and let's see what happens. This is definitely not how we want to deploy our applications to production. This is not how we want to deploy ideally anything to our Kubernetes cluster because we don't know what's really going to happen, right? So if we look at our environment, it's actually split into two parts. The left part is the untrusted zone, a public image, a public Helm chart, a public operator, which then also might be an image. And the right part, our trusted environment, our cluster, our artifact store, our registry. So somehow what we need to do, we need to move things from the untrusted zone into the trusted zone and ensure that we're only also moving things over that we expect to move over and not something else. So what we need to do is we need to establish trust and ensure authenticity of the artifacts. Are we really getting what we think we're getting? We need to get them into our safe zone, which can be somewhat tedious because we need to export everything, re-import it, or we need to use some kind of federation for registries, but it's still kind of inconvenient to get there. There's more convenience for some of these moving things into your environment and for installing applications using operators. On the other hand, I've also seen people always rather relying on more declarative approaches than operators because they want to see exactly what is happening to the cluster before they execute it. And operators might just be a binary inside a container that's running there. From potential solution space, there's two things that are definitely worth looking into. DCT, Docker Content Trust, which is by itself only a partial solution, obviously, to the problem, but it helps you to verify that certain images are coming from a certain provider. Obviously, if you trust that registry, that's a requirement here. And for Helm, we have approaches for Helm provenance and integrity that allows us to do similar things for Helm chart to ensure we're getting what we're actually expecting that we're getting. And this is also something that you should include into your delivery to ensure that only items can be executed against your cluster that you should be allowed to execute against that cluster. The last challenge we want to talk about here is really operations automation, but not so much at the infrastructure and container level, but really moving it up to the application level, and ideally doing this in a reusable format. So Kubernetes is great in handling generic application operations, restart, scaling, health monitoring based on health endpoints and readiness endpoints. But applications are managed not just on these health endpoints. Usually you have SLIs and SLOs that you use for your operations tasks to ensure that the application is running properly, that go way beyond it's just there or it's working. And there are also domain-specific operations that you're running that require custom logic. Like if your load gets too high, you want to switch to static content delivery versus calculating things at runtime. So what are your options here? So exporting the metrics is really easy. You can use Prometheus, you can use OpenTelemetry, which makes it really easy to expose those metrics. You still need to have a backend that consumes these metrics, obviously, but you can assume that the cluster has them available. For operations automation, Kubernetes operators, as the name already suggests, are a great choice here, as they can handle and work with these metrics and these environments. However, it's not really that well defined, or let's say standardized, on how the operator would get information about SLIs and SLOs that they should act on. Like, how would the operator know or even be able to access this information, which is stored most likely in a monitoring backend and can consume these metrics and alerts? There is also a project called Captain that I'm also personally involved in, that tries to solve, amongst other things, some of those problems and how you can use SLIs, SLOs, and put some automated operations logic on top of it, and also ensures that like all three things get tied together automatically.
Thank you, Alois, for a great summary about the new challenges and solutions we are facing in current application delivery ecosystem. It's very informative. So allow me to do a brief summary for this session. So we're basically seeing that there are new challenges and potential solutions emerging in the application delivery ecosystem. It's huge and it's important. We also notice that some of them are still missing in the current landscape, and some others need revisit or repositioning. We need to do something to reshape the whole landscape. And we also notice that the current structure of the landscape will need some kind of redesign so we can deliver the messages to our audiences to let the community know better what a specific project is really about, what kind of challenge it can be used to solve, and any potential use cases we can discover besides its main description. So all of these things can be delivered very well by restructure and refactor the current CNCF landscape. That's why we have the proposal in the SIG application delivery of the CNCF. And we want to add a new tab, which name is application delivery for CNCF landscape, which basically about the cloud native application management and development and focus on this ecosystem. So this is idea. And if you like this idea and you want to join us together to reshape the CNCF landscape, the SIG app delivery is really the best place for you to get started. So me and Alois as well as Brian are co-chairs for this SIG, and you can reach out to us through the Slack channel in CNCF Workspace. You can raise your discussion in our mailing list. And of course, the best way to join us in a discussion around things of SIG app delivery and the application delivery ecosystem is our SIG meeting, which is held every first and third Wednesday of the month. So I think the best way for you to get started is to check the agenda and notes to see what is currently under discussion. And this update on the landscape is actually one of the most important part for our recent work. So welcome to join the SIG app delivery, and we will be very happy to see you join us and reshape the CNCF landscape in the future. Thank you very much.